0 through 9. Now, what if I wanted to access the value of I here right after the closing curly brace for the for statement? Well, notice that I'll get a red squiggly line under I, and if I hover my mouse cursor over it, it says that I does not exist in the current context. Why? Because I is now outside of the scope of its definition. We defined I inside of the for loop. It's available inside the for statement itself plus in the code block below it, but not outside of either of those. All right, so we'll have to comment that out. So second, let's start, we'll continue by going and creating a string of j equals empty string. And what we'll do inside of our loop here is just go j equals I dot toString. Now let's go outside of our loop. Will we be able to access the value of j? So let's go outside of the for, and will we be able to actually print to screen the value of j? All right, we are not getting any errors, so let's run the application. And you can see that the last value that was inserted into j was the value 9. Since we defined j outside of the scope of this code block, of the for statement and its code block, we can access it inside of that code block and outside of that code block as well. All right. Next up, let's look at the at something like this, where we'll actually create what's called a field or a private field. So we'll go private static string k equals, and a private field is sort of like a property, except it's private in nature, but it is available to all of the members of the class. So we should be able to see k inside of our for loop. So let's do I.toString. We should be able to see it here as well in the outside of the for loop, like so. Let's go ahead and run the application, and you can see that second console.write line will also display the number 9. But the real question is, what if we were to create a helper method, static void, and we'll just call this helper method. And here we'll go console.write line, and we'll say this is the value of k from the helper method, and we'll do that. Now here we'll call the helper method like so. Will this work? Will we be able to access the value of k as it was set inside of our for loop outside of our static void main? Let's run the application, and you can see that we can in fact get the value of k from the helper method. Why? Because k was defined at, I guess you could say, the class level. It is a sibling to static void main and static void helper method. Therefore, it's accessible to each of these as well as any of their inner code blocks. All right, hopefully this is starting to make sense. Let's go inside of the for loop now, and here what we'll do is a simple if statement. So if I is equal to 9, so on the very last run of this, then let's declare a string called L, and we'll set that to string, the I to string, and then outside of that we'll go console.write line the value of L, and as you might anticipate, we will see that L does not exist in the current context. Why? Because we declared the value of the string variable L inside of the if statement's curly braces. Outside of those curly braces, it's no longer accessible, so we have to comment that out. All right, so hopefully this solidified in your mind many of the combinations that we can use in determining whether something's in scope or out of scope. And if you had any confusion about this, hopefully that cleared it up a little bit. All right, so now let's move on to the larger topic of accessibility modifiers. We've been creating classes, specifically the car class up to this point, and whenever we were creating methods, I would typically use the public keyword. Occasionally I would use the keyword private like I did here in line number 11. Private and public are both accessibility modifiers. They're used to implement a tentative object-oriented programming called encapsulation, which is actually pretty important. So in a nutshell, you should think of classes as black boxes. And whenever you think of a black box, maybe you can think of like one of those old style television sets. Maybe your parents or grandparents had one. I remember as a kid us having one. There were no remote controls. You had to get up, walk across the room, and actually turn the dials of the TV in order to tune to either VHF or UHF channels. You had another volume maybe or a dial where you would adjust the volume. You had an antenna in the back, so you would connect this wire out to your antenna, and you had another one where you would plug it into the wall. And everything else about the television was self-contained. Now, as a kid, I was fascinated whenever my dad would pop off the back of the television set, and he'd go and try to fix it by changing out the tubes. And it's always seemed like magic to me because I knew absolutely nothing about the innards of televisions. All I knew were the public interfaces, the button for on-off, the dials to turn the channel, the dial to turn the volume up and down, the antenna, whatever that did, and the little plug that would obviously give it electricity. But frankly, in order to use the television set, that's all you really needed to know, right? You did not have to know anything about how a television worked. All you really needed to know was how to plug it in and change channels, turn it on and off, and then adjust its volume. And that is exactly how your classes should be treated. All the important behind-the-scenes functionality should be encapsulated behind interfaces like public methods and public properties. Now, classes might, in fact, have private fields like we looked at here in line number 11, or they might have private methods that are used behind the scenes to enable all the magic that goes on inside of that class. But the consumer of the class shouldn't know anything about the inner workings of the class in order to work with the class, to operate the class. All they need to know is what's publicly exposed through the public properties and public methods. So in a nutshell, private means that a method can be called by any other method inside of the same class. So I've used the term private helper method a number of times accidentally. Essentially, when I use the term private helper method, I'm talking about a private method that adds some additional functionality to those public methods that are exposed to anybody who needs to work with the class through that method. A public method is what's actually going to be then called by somebody outside of the class, some other code outside of the given class. And private methods are only going to be called by members inside of the class. Okay, so let me do this. I'm going to paste in some code to recreate our car class. And here I have a public and a private method. The public method is called do something, and the private method is called just helper method. All right, and these are not very interesting examples. I want to keep this as simple as possible. Now, from the outside of this car class, let's just kind of roll this whole thing up here and save it. And now whenever I want to go here inside of my static void main, I might want to work with the car class. So I'll go car, my car equals new car. And then I'll do my car dot, and notice that I can only see the public method do something. Now, I might happen to know there are other methods also inside this class, but I can't see them from outside. Their visibility is hidden to me because they're marked as private. All I really need to know is how to use the do something method, and if I understand that I can call that all the implementation details will be hidden from me, but it'll work as I expect it to work. Here you can see that it merely prints out the words hello world. All right. Now, how it does that, whose responsibility inside of the class it is to actually display that, that's none of my concern. All I need to know is how to call the public method do something. Okay. So in a sense, the consumer of the car class has absolutely no idea that that helper method even exists. All it really knows is that there's one public method, and it could call that public method, but it doesn't know any of the hairy implementation details, right? Now, I use the term in a sense, that in a sense, the consumer of the car. The consumer is going to be a software developer, and a software developer is going to be able to drill in and say, oh, I see how it's doing its work. It's actually making a call out to this other private helper method. And so, you know, there is a sense in which it is public to developers, but it's private from the perspective of the consumer, which is this main method. It can only see the do something method, not the private helper method. Okay, that's all we really mean here. Now, admittedly, this is extremely mundane. It's a simple example that's only real value is to illustrate the notion of encapsulation, that we typically want to hide the implementation of our classes behind well-known public interfaces, in this case, a friendly method called do something. And the purpose of this lesson is to better understand the notion of scope, because we said that once variables, especially variables that contain object references, fall out of scope, their objects will be garbage collected. Furthermore, it's important to understand that there are parts of classes that you have access to and parts of classes that you don't have access to. Now, if you ever decide that you want to create your own custom classes someday, even a library of classes that represent the business domain of your company or of your specific application, it could be a game, you should strive to expose public methods and give a simple, straightforward, obvious way to call the public methods from your class, but keep all the other helper method, all the other internals privately tucked away and not available to prying eyes. So you don't want a developer to simply go fiddling around inside of all of your methods and use your class in a way in which it was unintended. You want to give them a way to use your class properly through the methods that you've designed and that you've made available through public interfaces. And this also will help to remove any ambiguity in the usage of your classes. And it should be much cleaner as well. All of these things were under consideration whenever the developers built the .NET Framework class library. In the .NET Framework class library, methods and properties are exposed using the public keyword. Now, they might also be using private fields and private methods behind the scenes, but you would never know. They may use other types of accessibility modifiers as well. There's actually a couple available called protected and internal. However, these are primarily for whenever you're working either in a rich inheritance relationship between classes and you're building a rich inheritance hierarchy between classes, or whenever you're working with a very large library that's compiled into separate assemblies. That's when some of these other accessibility modifiers might come into play. They're topics that are beyond the scope of this absolute beginner series, but topics that I do cover on Developer University. So if you want to know more about object-oriented programming and encapsulation, by all means, go ahead and... All right, we are well past halfway through this course. You're doing great. We've already covered the most difficult material already. Now we're just adding on details. So you should be encouraged by that you're still plugging away at this. And you're doing great. We'll see you in the next lesson. Thank you. Hi, I'm Bob Tabor with Developer University. For more of my training videos for beginners, please visit me at devu.com. Previously in this course, I said that the .NET Framework class library is merely a collection of classes each containing methods filled with functionality that we can utilize in our applications, but we didn't have to write. Microsoft has spent tens of thousands of man-hours building and maintaining this library of code, and we can benefit from it by merely calling into its classes and methods inside of our applications. Now, the framework class library is massive. Thousands of classes, each with their own set of methods. And so the developers of the framework class library wisely decided to split this library of code up into multiple files. Just imagine if you had to load the entire library into memory every time you wanted to run your application. First of all, it would be excruciatingly slow, and then secondly, it would probably take up the majority of your computer's memory. And so they split up the code into multiple files. These code files are called .NET assemblies. In fact, even the applications that we build, they're ultimately compiling into .NET assemblies. As you can see, I have a new project called Assemblies and Namespaces already open. I've added 2 lines of code. If you want to pause the video and catch up, that would be great. In lines 13 and 14, I'm merely printing hello world to the screen and then pausing the execution of the application. However, even in this application, a executable .NET assembly is being generated the very first time that we run the application while we're debugging. So now, if you want to take a look at what happens, go to your projects directory, and inside of the project folder, you'll see that there's a bin directory. We avoided this very early in this course, but now I want to talk about it briefly. The bin directory will contain both a debug and a release version, ultimately a release version. The debug version will contain additional files required by Visual Studio to connect to the execution of the compiled executable. This allows us to step through the execution and pause the execution line by line in the Visual Studio debugger. Now we can additionally then, after we've created our application and thoroughly debugged it, we can say I want to create a release version of the application, and go to Build Solution in the Build menu, and it will create a version of our application without any of those debugging symbols, without that connection to the debugger. If you look at the file system, you might be a little confused to see that it also has a lot of those extra files in there, but they're basically ignored. But that is what's going on behind the scenes. Notice that in each of these cases we're building an executable file that will run, and we could even just double click it and run the application from here like we did before, right? Now that is different from the type of .NET assembly that allows you to create a library of code that can be shared across multiple projects. In that case, you'd be compiling a project into a .dll file extension. And we can create a code library. I'll show you how to do that in another video. But at any rate, the .NET framework has to already be installed on any computer where you want your application to work or to run. Fortunately, basically every copy of Windows already has the .NET framework runtime and the class libraries installed in a location that's globally accessible called the Global Assembly Cache. And so every .NET application can reference the same set of assemblies in that one spot on your hard drive. Now you might say that whenever you build your application and set up your application, you may not realize that by choosing to create a file new project and then selecting the console window project template, you were actually creating references to those files in the .NET Framework class library. That's one of the functions of the setup routine for a project template. So if you take a look at the references node underneath your project in the Solution Explorer over here on the right hand side, you'll see that there are some references already to these things like system.core, system.data, system.net, and so on. All right. Now, we'll talk about what these are in just a moment, but that's indicative of the fact that we have references into files of the .NET Framework class library that the creator of the console window application thought we might be or might find useful at some point. All right, so we'll come back to that in just a moment. Now, sometimes you'll need an assembly from the .NET Framework class library that has not been referenced, and I'll demonstrate how to do that in an upcoming lesson. Or perhaps you need to add a reference to an assembly created by a third party, maybe even yourself. I'll demonstrate not only how to create your own class library, but then also how to create references to third-party assemblies as well. Again, there are tens of thousands of classes defined in the full .NET Framework class library. In a few cases, the same class name was used, or at least there was the potential for it to be used. And so when that happened, the creators needed a way to be able to tell one class from a different class. And so they introduced the notion of namespaces. And namespaces are like last names for your classes. So think about your name or my name, for example. Somebody might say Bob loves coffee. And you might say, well, which Bob? There's like a billion Bobs in the world, right? But if somebody were to say Robert Theron Tabor likes coffee, well, that narrows it down. I'm pretty sure that I'm the only person in the world that has that combination of first, middle, and last name, all right? So I could either use the full name, Robert Theron Tabor, to reference one person, or once we understand the context of who we're talking about, maybe we're talking about only people in this room, then you might say, well, Bob likes coffee, he's the only Bob in this room, so they must be talking about Bob, right? So the same idea works with your code. We could use the full name of the classes that we need inside of our application. So for example, the full name of the console class is actually system.console.writeLine, all right, or the system.console class, right? That's the full name of the class, and then we're calling the method in that class. However, you'll notice that I didn't have to use the word system here. Why not? Well, because we used a using statement at the very outset of this code file, which says, I want you to look inside of these namespaces whenever you find a class reference that you don't recognize. And so the C# compiler, it finds the word console and it says, I wonder where that came from. And it begins to look through the namespaces listed in the code file, and it says, oh yeah, I found a class name called console inside of a namespace called system. All right, and so it thinks, all right, well, that must be the console class that he's talking about. Now, occasionally you might have two classes with the same name and you've added using statements for each of these inside of your code file. When that happens, you merely need to disambiguate by adding the full name of the class instead of relying simply on the using statement. Now you'll notice here that by default the program.cs file has a number of different using statements. In my text editor, they're kind of faded out a little bit, which indicates to me that they're not being utilized at this moment. So we could remove unused using statements from our code and our code will compile just fine. Again, this is a convenience for us that was set up for us by whoever created the project template for a console window application. So to further illustrate this idea, let's talk about how we can go about using the .NET Framework class library to do meaningful things and how we would go about finding the source code or the classes we need to do something cool in our application. So for example, maybe I want to write data to a text file. How could I go about doing that? Well, I might open up bing.com and I might search for, and I'm going to type in site Microsoft.com, so I'm going to limit the search results to just those that are returned by Microsoft.com. All right, this is going to help me find the documentation specifically created by Microsoft as opposed to third-party articles or whatever the case might be. So site:/Microsoft.com, and then I might just say write to a text file and then using C#, right? And so one of the top results are from msdn.microsoft.com, and MSDN stands for the Microsoft Developer Network. This is your primary source of information as a software developer on the Microsoft platform. And so in this case, here's a how-to article that will describe the code that we would need to write in order to write data to a file. Here's a long code example. In fact, it gives us 3 examples in one, and we could use one of these examples in our application in order to write data to a file. And we might decide to go ahead and use this second example. It comes close to what we want to work with here, and I copy it and paste it into my application. And I might remove some of the extra information here just because I don't need it. And I may need to modify this path. I believe I created a folder called Lesson 17 for this purpose. And notice that it's going to use a class name file and a method called writeAllText. Now in this particular case, notice that we already are given the full namespace of this file class, system.io.file. Now what we could do is actually remove that from here and go up and add a using statement for system.io, like so. All right, and notice that the compiler will find it and we'll be able to run our application. And got a little message there because I was in release mode. Let's go back to debug and start that over again. All right, and we don't get any feedback there, but if we were to open up our Lesson 17 folder, we would be able to find the text in a text file. Great. Okay, so now we can use that little snippet of code to do what we want to do. But notice it all started by searching on MSDN, finding a code snippet that we could use, and then we can modify it and add our own text here that we want to write this to our file, right? Okay, so that we can start stitching things together. So that's one thing that one way that we can find the features inside of the .NET Framework class library that we need is to search on MSDN. Let's try one more quick example, and let's go back here, back to bing.com, and here again I want to go site:/Microsoft.com, and then I want to do C# download HTML as a string, and I might find another reference. Now this is a different style of web page. There is one web page on MSDN for every class and every method in the .NET Framework class library. So in this case we're looking at a specific page for this download string method. And if you were to look at the remarks and some of the the syntax and some of the exceptions that it would throw, what we ultimately get to is a little snippet of code that we can copy and that we can paste inside of our application. Now notice what happens this time. It does not recognize the term web client. Why not? Well, we may not have the assembly referenced in our project, or we may have the assembly referenced, but we do not have a using statement that would include the web client class. So to remedy this, I'm going to hit Control period on my keyboard, and it says that it found this class in system.net. So we can automatically add a using statement for the system.net class by merely hitting the Enter key on my keyboard, or I can just go ahead and say, let's go ahead and use the full name of the class here. I'll choose the first option using the arrow keys and then the Enter key on my keyboard. Notice what happens. It adds a using statement for system.net, and then notice that the web client class is now found. It is obviously in a different color. There's no red squiggly lines, so it looks like it found the correct class that we're looking for. Now we merely need to give it a URL, so let's try msdn.microsoft.com, like so, and then we will just write this out to screen reply. And then we might even rework our application and attempt to save that into our text file as well.